So I'll start the recording session. I'm sharing my screen. Okay. So in the last class we seen about the different value set and data types. What are the data types like reg data type, net data type? We already seen, no? Okay.
Yes,
Yeah.
sir.
Today we'll see about the next topic. That means here, if you consider in the last class we discussed, suppose if you declare wire A, this is of how many bit?
1 bit, 32 bit.
One bit. Yeah, this is one bit.
1 bit,
Okay,
1 bit.
one bit.
Hmm.
Suppose reg A also. Reg A, if you declare, so this is of what? One bit only. Okay.
Hmm.
Suppose like if I want to declare multiple bits. Okay. Suppose within one variable, if I want to declare, suppose if you take 2 cross 1 mux. Okay. So 2 cross 1 mux means two inputs and one output and one selection line. Okay. So here this is actually I naught and this is I1. So within this one variable, I want to declare this I. Okay. So what I can do? Okay. So here there is a concept called vectors will come. Okay. So what is vectors? Vectors is actually grouping the multiple bits into single variable. Grouping multiple bits, multiple bits into single variable. Okay. So that is actually vector. Okay. So in digital also we already seen now vectored mux.
Yes, sir.
Have you remember? So there also we declared like 2 down to 0, 2 down to 0 A and 2 down to 0 B, like this I told, no? So
Yes.
that is same concept. Okay. The syntax will be like this. Okay. Syntax is uh, data type and range and next variable. Data type, range and variable. Okay. So data type can be what data type we can use? I can use reg or wire data type. I can use reg or wire data type, and range can be like MSB down to LSB. Okay, this is actually what down MSB down to LSB and LSB to MSB, LSB to MSB. So this is actually MSB to LSB. So mostly this will not use. We'll use this one only. Okay, MSB down to LSB. Okay, is it fine? Vectors is fine.
Yes, sir.
Okay.
Yes, sir.
Suppose if you want to store, so if you want to store some 3-bit number, okay. So 3-bit number. So let us take 011. Okay. How we are representing? How we will represent? We already seen the value set, no? We already seen the number representation.
So 3-bit binary 0
Three
1.
tick binary 011. Okay. Like this we representing, no? So here
Hmm.
how to write the code? So module example. So I'm declaring reg 2 down to 0. This is actually how many bit? So how
3
many
bit.
bit? 3 bits, no? So the size will be represented before the variable. Okay. So here if I'm using reg means I need to use initial a equal to what? 3 tick binary 0 11 and end module. Like this you need to write. Did you understand this code?
Yes, sir.
Okay. So actually like 0 double 1 means what? What is the index? So indexes is this is 0 1 2. So this is actually my index. We call as the index. Okay. So that is 2 down to 0. Okay. Suppose like 4-bit value is there. 4 tick binary 1010 is there. Okay. How you declare the vector? Tell me.
3 down to 0.
Yeah. Reg 3 down to 0 A. I need to declare like this. Okay. So this is the standard representation. Okay, this is so mainly suppose if I want to represent like 0 to 3, yeah, this mainly we are not using this. Okay, so we are using like MSB will come first. MSB down to LSB. So MSB. So here The value is, let us take 1010. So this is my MSB bit, and this is LSB bit. Okay. So the size will be declared. So 3 down to, like 3 down to 0. 3 down to 0 means here how it will store. That means horizontally 4 locations will be created. Okay. So horizontally 4 locations will be created, and here it will store 1010. Like this it will store.
Yes, sir.
Okay. Yeah.
Yes, sir.
Did you understand the vector?
Yes, sir.
Okay.
Yes.
Suppose next if you take, let us take range 5 down to 0, I am declaring m. Okay. Here I'm making some value. Suppose m equal to, let us take 6 tick binary, 0, 1, 1, 1, and 0, 1. Okay. So I'm declaring. Okay. So that means here I told you horizontally how many locations will form?
Six slots.
Yeah, 6 locations will form. So this is 0, 1, 1, and 1, 0, 1. Okay, like this it will form. Okay, so
Yes.
there is a concept called vector slicing. Vector slicing. Okay, so what is this vector slicing? Let us take TB, module TB. I am declaring like reg 5 down to 0, m. I am declaring reg 1 down to 0, n. 1 down to 0, n. So initial m equal to 6 tick binary. So whatever the value is there, I'm initializing 0, triple one, 0, 1, 0, triple one, and 0, 1. End module. Okay, end module. Like this, I'm writing. Suppose if I give like n equal to m 3 down to 2. So what is the value of n? Tell me here.
Sir, 1 1.
1 1.
0, 1, 2, 3, 4, and 5. Okay. So this separately I can access these 2 bits. So n equal to what? 1, 1. This is actually vector slicing. Suppose if I want to access only MSB, so I can access like this m of 5. N equal to what? M of 5. What is n?
0.
0, no? 0. So MSB, whatever the MSB is there, that will be stored. Okay. So this is actually vector slicing.
Yes, sir.
Did you understood what is vector slicing? This is mainly one important interview question they will ask. What is vector slicing?
Sir,
Okay.
I have to ask a question. As the most bottom line, we took n equal to m 3 down to 2.
Hmm.
So we are taking the 2 bits of the m on the position of 3 and 2, and
Yes.
assigning those
Hmm.
numbers to the
Ah.
value of n. Sir,
Yeah. Yeah.
we are taking the 2 bits, and we have already decided the size of n equal to 2 bit in the
Ah.
range 1 down to 0 n.
Ah.
Sir, suppose somebody took size of the n like reg 1 down to 0 n, and at the bottom line he take more than 2 bits of
Okay.
the m. Then
Hmm.
sir, then what will happen? Just
That will
random
not
question.
execute. Suppose if you want to execute that n value, that will not
Huh?
execute. Why? Because what is the size? Only 2 bits now. Only 2 bits will be executed. Suppose I understood your doubt. N
Yeah.
equal to, suppose if I give like
4 down to
4
2.
is to 2. Yeah, 4 down to
Yes.
2. 4 down to
4
2.
down to 2.
So 4 down to 2 means actually you need to access how many bits? 3 bits. Okay. So 3 bits, that is
Yes.
111. So when you want to print, that is so dollar display the value of m. Okay. If you want to print dollar display in the quotes the value of m, the value of m is percentage b comma m. So then
Hmm.
it will display the value of m equal to what? Only 1, 1 only it will display. So this will be
Only
not
one.
displayed. Why? Because size is 2 bits only now.
Got it, sir.
Okay, yeah.
Got it, sir.
Suppose if you declare like range 1 down to 0, A comma B comma C. Okay. So what is the width of A, B, C? Tell me.
2-bit.
Yeah. All the width A is 2 bit and B is 2 bit and C is also 2 bit.
2-bit.
Okay. Okay. Yeah. Next, suppose let us take um, I'll give okay, next slide I'll go. Suppose module TB range 1 down to 0 A semicolon B semicolon. Okay. So what the compiler give the error? There is some error.
For
There is
B,
some
it will
compilation
give
error.
error.
Uh,
For B, it will give error because data type nor the size is specified.
yeah, for the B you declared only variable. So here what is this missing? Data type is missing. You not declared the data type, no. So data type is missing. Okay, you need to careful about this. Okay,
Hmm.
and did you understood this?
Yes, sir.
Okay, let us take module example input input a comma b comma 1 down to 0. Let us take I am giving C. Okay, semicolon output 2 down to 0 sum. Is there any error in this?
Sir, semicolon shouldn't come, I think, after C.
Yeah, within the bracket. So semicolon. So you'll get a compilation error. Okay.
Yes, yes, sir.
So semicolon means what? End of the statement. Okay. Here what
Hmm.
should come? Comma should come.
Hmm.
Okay.
Yes, sir.
Semicolon is actually within the bracket. We should not. So we should not use this semicolon within the bracket. Within the bracket. Okay, so semicolon is actually it's a end of the statement. Okay, so comma means what? You can declare like this. Okay, this is the last class I told you, no, this is style 1 or style 2.
Yes, sir.
Style 2, no. Style 1 is actually you are declaring the ports and separately you are declaring the inputs and outputs. This is style 2, so we can declare the inputs and outputs within the bracket itself.
Yes, sir.
Last class we discussed, no,
Yeah,
did you
yeah.
understand? Yeah,
Yes, sir.
okay, yeah.
Yes, sir.
And next one is very important. Let us take suppose the reg 2 down to 0 a. If I give a equal to 6, okay. So if I want to display in binary, so dollar display the value of a is a percentage b comma a. What is the value of a? Tell me. If I give like dollar display statement, okay, dollar display the value of a is percentage b comma a. What is the value of a? Tell me.
So 110.
Yeah, this is 110. Okay, 110. Okay, it will display in terms of binary. So the size is what? 2 bits only. Next, what I will do, let us take here, I will declare one more variable, reg 2 down to 0, some b I will give. Okay, so here I will give b equal to -6. Okay, I will display same thing. So same thing I will display. Dollar display the value of b is percentage b comma b. What is the value of b? Tell me.
Sir, it maybe perhaps it can show an error because signed bit must be also there, and uh, it may it require 4-bit.
It
So
will display.
perhaps
It will display. It will display in terms of binary. We
so
already discussed this one in. Digital we already discussed.
You will calculate the two's complement and then
Yeah, it will display in terms of two's complement. Why two's complement?
Yeah, yeah, okay, okay.
Why not sine magnitude and one's complement?
Because two's complement maintain the same size.
I told
Is that
you during two's complement. Can you remember?
like
sir? Because it is the another way to store the number.
Mhm.
Uh,
In the case of one's complement, there is an issue with zero.
Hmm. In sine magnitude and one's complement, if you want to store plus and minus zero, so there are two values are there. Okay. Suppose if you are representing in suppose if you are representing in one's complement, so two representations are there. Compiler can't decide whether to store plus zero or minus zero. But in two's complement, for plus zero and minus zero, only one representation. There I stressed more that we are representing when you are using a hardware or when you are using a compiler, so that will store when you give a negative number representation, separate topic is there no in digital.
Yes, sir.
Sir,
So,
actually, in
so
my class, this zero concept was skipped. We have not
uh,
attended this one. Sir, I
uh,
request you, can you elaborate just for 2 minutes this thing?
actually, like suppose if you take minus zero, okay. So minus zero means if I want to represent sine magnitude and one's complement and two's complement, okay. So
Yes,
how
sir.
you can represent minus zero means sine magnitude means let us take 3 bits. 3 bits means what? Sine magnitude means 1 followed by 0 0. Okay. One's complement means what? For 0 0 0 0. This is actually plus 0. Okay. This is actually plus 0. You need to apply one's complement. What you are getting? 1 1 1. Okay. For
Yes, sir.
two's complement, what you will get? Just you need to add 1. No?
Hmm.
So this is what. So you need to add. Uh, uh, so for 1 1 1 3 ones you need to add 1. Okay. So for one's complement you need to add 1. This is actually one's complement. 1
Yes,
plus
sir.
1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. If you are getting a
Hmm.
carry, you need to discard the carry. So that means minus 0 is what? 0 0 0 only.
Yes, sir.
Okay. Suppose
Hmm.
plus 0 if you take. Plus 0 means sine
Hmm.
magnitude, how we are representing, this is actually value and this is actually
Zero.
sign bit, sign bit.
Sign bit. Sign bit.
MSB. MSB is 1 means negative, MSB is
Negative.
0 means positive.
Positive.
Okay.
Positive. Hmm.
Okay. What is one's complement? Again 1 1 1.
Hmm.
Okay. And again two's complement if you take 1 1 1, if you add 1, so 0, carry 1, 0, carry 1, 0, carry 1. You can discard the carry. So if you observe here, so for plus 0 and minus 0, in the sign magnitude, you have two representations.
Yes, sir.
In one's complement also, 1 second. In one's complement, 1 second. This is 1 second. For the minus 0, actually one's complement is 0 1 1 you will get. For 0 1 1 you will get. For two's complement, triple 1 you will get. Okay, two representations are there. But in the one two's complement, you have only one representation.
Got it, sir.
Okay,
Got
so
it.
that's why here minus 6 is there. Okay,
Hmm.
minus 6 is there. Minus 6 is there. How to represent? So you know for plus 6. Okay, so you know like plus 6. Okay, how you represent? This is actually um, 6 you know.
Four.
6 is
Ah.
3 bits now.
Ji,
1
ji.
1
Hmm.
0.
Hmm.
Okay, what is
Hmm.
the ones complement? 0 0 1. Adding 1 to this, what you are getting? 0 1 0. You will get.
Yes, sir.
Okay, see here
Yes, sir.
0 1 0 means here you need to add 1 over here. Actually, it will not declare. Why? Because size is 3 bits only. So 1 2 4 and minus 8. 1 second. Minus 8. Yeah, minus 8 plus 2. How much? Minus 6, no?
Yes, sir.
So like this it will display. It will display in terms of, if you are giving negative number, it will display in terms of what two's complement. Is it
Okay,
fine?
sir.
But if you want to display, like if you want to display this value in decimal, it will display 2 only, not -6.
Mm,
It will display in terms of 2. Okay. Y
mm,
means this wire data type, wire and reg are unsigned data types. Unsigned data types. Unsigned data types means what? So when you want to display in binary, it will display in terms of 2's complement only. But when you want to display in terms of decimal, it will display this value. What is this value? 2. 2 it will display. It will not display -6. Why? Because by default you need to remember wire and reg are unsigned data types. Okay. So if you want to display signed, what you need to do? Reg, here you need to use signed. Like this you need to use. Or otherwise you can use integer data type also. This is a signed data type. So what is the conclusion? Reg and wire are what type of data type? Unsigned data types.
Sir, what about one and board?
Those are also unsigned data type.
Sir, that means if we took reg and wire data type for any variable,
Hmm.
we will always have to assign unsigned value to that variable that may be only positive. Is that right, sir?
No, actually, like if you are suppose 6 means 6 means 110. If you want to display in terms of binary or decimal, okay,
Hmm.
it
Hmm.
will display 110 and it will display 6. Okay. Suppose if you are giving b equal to -6. Okay. So if we are using dollar display, the
Hmm.
value of b is percentage b. If you want to display in terms of binary, okay, how it will be displayed? 010. In terms of two's complement, it will display. Okay. And again,
Okay.
same value if you want to display in decimal, it will display this value. What is this 2? This
Okay.
is a separate concept is there, that there I will explain you with coding. Okay. For now, you
Sir,
remember that.
sir,
Hmm,
sir, I just want to summarize that if we are using reg or wire data type, the compiler will treat variables value like a unsigned number.
hmm, hmm,
It will operate. It will uh, it will never count the MSB. It will never see the MSB for any
hmm,
sign. But
hmm,
if we provide that variable data type as integer, then compiler will see for MSB as a signed number. Is that right?
yeah, yeah, yeah. Okay. So negative number means it will display in terms of two's complement. But if you
Hmm.
want to display that value means that display in terms of that magnitude. Okay. Why? Because reg and wire data types are unsigned data types. Is it fine? Hello.
Yes, sir.
Yes, yes, sir.
Yeah.
Listen, sir.
Next is integer data type. Okay. Integer data type. So what is integer data type? Integer data type is actually the width. The width of integer data type is 32-bit. Okay, 32-bit. And this is a signed data type. Signed data type. And default value. Can you say what is the default value? Default value unknown. Default value is what? Don't
Unknown,
care or unknown. Okay.
unknown.
Suppose
Hmm.
if I give like integer a equal to 2. Okay. So how it will store by default? Width is how much? 32-bit. So 32-bit means it will store in terms of 32-bit. So
Hmm.
0 up to so on. So it will store 10 like this. It will store.
Yes, sir.
Okay. So this is actually
Yes,
31 and 1 and 0 like this. Okay. So
yes, sir.
here is vector slicing is possible in this integer. Suppose like if I want to declare integer like 3 down to 0 a is it valid?
Yes, sir.
It's not valid. It's a packed data type. Packed data type. That means 32 bit is packed. So vector slicing is not possible. Okay. Vector slicing is not possible in the integer data type. Okay.
Yes,
Why?
sir.
Because that is 32 bit. 32 bit is inside packed data type. So vector slicing is not possible. Not possible. So
Yes, sir.
we cannot access this means these single bits we can't access. We already seen in the vector, no?
Yes, sir.
Okay. Yeah. Suppose a vector example, a integer example, you try in the Vivado you can try in the EDA playground. Let us
Sir,
take module. Yeah.
actually, this vector is not a pure data type, right? Because
This is not a data type. Like vector means uh, for uh, for representing the multiple bits, we are using the vector. Okay. Reg and net are data type. This wire and reg. Mostly we are using wire and reg. So if you want to group multiple bits into a single, we will use a vectors concept.
mm,
Vector slicing, I told you, no? Vector slicing means if you want to if you want to access a group of like slicing of data, that is actually vector slicing. Okay, some single or multiple bits of data in between that, that is actually vector slicing. Okay, so just to try this code and tell me the output. Let us take a integer. I'm declaring m. Okay, initial begin. Initial begin uh, m equal to I'm giving -2, m equal to -2 dollar display the value of m is percentage d comma m end and end module. Okay, can you try this code?
Right now, sir?
No, means after this
yeah,
class just tomorrow you update me. Okay.
that's
Yep.
Yeah. Next float data type. Float data type. So float data type means it is like we'll use for storing the decimal values or fractional numbers. Fractional numbers we'll use float data type. Okay. So here the size is 64 bit. Size is 64 bit, and default value is x. Default value is x, and this is also signed data type. We can store negative numbers. Okay. So, so here, so in the Verilog, I told you synthesis. What is synthesis?
those
Sir,
codes we can.
converting the code into the gate level netlist.
Yeah, converting the code into gate level netlist. Okay, into hardware or gate level netlist. Okay. Now tell me, there are like synthesizable constructs, and non-synthesizable constructs. Okay,
Yes, sir.
non-synthesizable. In non-synthesizable constructs. Okay.
Hmm. Hmm.
Uh, one more data type is there. That is one more data type I will tell you. Last data type, time data type. Time data type. Okay. So time data type, it is used to track the simulation time. Used to track the simulation time. Okay. Simulation time. And here the size is 64 bit. Okay. Size equal to 64 bit. Okay, and default value equal to x, and this is unsigned. Time cannot be negative, no?
Yes.
Unsigned data type. Unsigned data type. Okay.
Yes, sir.
Now tell me, we discussed so many data types, no? What are the synthesizable data types and non-synthesizable data types?
Synthesizable are wire,
Yeah, wire,
Reg.
Reg.
reg,
war, band,
hmm?
war,
Yeah. Wire means here net
war.
data. We can say net data type. Yeah, net data type. Yeah,
Hmm. Sir,
Okay.
war and WAN.
war and WAND. Yeah.
WAN.
Mm.
Integer and float are non-synthesizable.
Integer is a synthesizable.
Okay.
Okay.
Once integer is a synthesizable. Okay,
Hmm.
integer is synthesizable. Vectors,
So we can include the float also.
float is non-synthesizable. We can't make hardware with float. Float is
Okay.
non-synthesizable.
Time also use
Sir,
in the
vector is also. Acha,
Time is
vector is
also
a construct.
non-synthesizable. Time
yes.
is not non-synthesizable. Why? Because we are using time in the test bench only. We can't use
Hmm.
in the hardware. Okay.
Yes.
RTL
Sir,
design we can't use. Yeah.
can you give an example where we will be using integer for synthesizable first?
Yeah. I will show you with the code. Okay. I will show you with code. Okay. In the vectors and arrays, I will show you the example. Okay. Yeah.
Hmm.
Next is actually next is arrays. Arrays. Okay. What is arrays? Just one
Sir,
minute.
group
1
of
minute. I'm
common.
getting a call. 1 second. 1 second.
Yes.
ఫోన్ చేసిన చెప్పు నేను తీసుకోలేదు ఓకే సో నెక్స్ట్ ఈజ్ arrays so arrays what is an array so we already seen the vectors no am I
Collection
audible
of
yeah
same
vectors
elements.
vectors we already seen okay so in the vectors so example we already seen okay reg 1 down to 0 a okay so that means in vector size is declared before the variable no
Yes. Sir.
before the variable okay so array okay if you take the array so example size is in array what do we need to do so we need to size is declared after the variable
Yes, sir.
a1 down to 0 okay size is declared after the variable okay suppose if you take the example we already seen the example related to vector okay suppose reg 2 down to 0 a and a equal to 3 tick binary 0 1 1 okay so how it will store tell me horizontal it will store no
Yes, sir.
so like three locations will form so 0
Hmm.
1 1 this is index 0 index 1 and index 2 okay so
Hmm.
if you come coming to array reg let us take a 2 down to 0 2 down to 0 so reg 2 down to 0 means so how it will form means it will form like three locations vertically okay that is the difference between um, vector and array okay
Sir, each location in the array, there are three locations. Each
Hmm.
location will be single bit na here.
Each location will be single bit only suppose
Single
if you
bit
take
only.
one if you take one example suppose
Hmm.
module test I'm writing begin
Hmm.
initial begin. So here I declared the array reg a 2 down to 0 a 2 down to 0 so that means how
Hmm.
many locations are there
Three locations.
three locations okay So here how to declare means a of 0 equal to what? 5, and a of 1 equal to 9, okay, and a of 2 equal to,
Hmm.
if I give 3, okay,
Hmm.
and end module, okay. How it will
Hmm.
store? So that means there are three locations will form. So three locations. So this is location 0, location 1, and location 2. Okay. So normally, I told you, know, any decimal value it is giving, it is converted into what? Binary, no?
Yes.
Yes,
Yes.
sir.
So 5 is actually 101. So this LSB bit will be stored in this location.
Yes, because it is a
Okay.
single bit we have
Yeah, single
defined.
bit. One
So
1001. This one will be stored here. And
only LSB will go there.
yeah, LSB will go there. Okay, one will be stored. Like this, it will store. Okay.
Hmm. Hmm.
Suppose if you take one more example, suppose module test, reg 1 down to 0, a of 1 down to 0. Now tell me,
So there are
this is
two
what?
locations.
This is what? This size I declared before the variable. No, what is this? Hello? Hello? Yeah, it is disconnected.
Yes.
Okay. So if size is declared before the variable, what is that?
Vector.
Yeah, it is a vector.
Vector. Yeah. So size is declared before the variable, that is actually vector. Okay. And size is declared after the variable,
Array.
array. Okay. So this is the combination of what? Vector and array. So that means
Hmm.
total, how many locations are there?
Two locations.
Two
Two
cross.
locations. Two locations. Okay. So in two, so there are two locations. So this is what? Location 0, location 1. So in each location, how many bits we can accommodate?
2 bits.
2 bits. Okay. So that means each location consists of what? Each location consists of 2 bits. Did you understood?
Yes.
Okay. So suppose like if I want to develop a memory such a way that I want 32 locations. Okay. Width of each location is 8 bit. 8 bit is width of location. Okay.
Yes.
So that means I
Yes.
want a memory like this. Suppose here if you see, so each location width is how many bit? 8 bit. Okay. This is 0 to 7. Okay. And like this, you have how many locations are there?
32.
31. 0 to 31, no? 32.
Yeah, 30, 31, 31. Hmm.
31. So how to declare? Tell me.
So the array will be 8.
Reg,
No, no. Vector will be 8.
yeah,
So reg
vectors,
31 down to 0.
vector
Sorry,
7 down to
yeah,
0, no?
7 down
7
to
down to
0.
0, mem of,
Variable. Yeah.
let us take variable, mem of
Hmm.
31.
31 down to 0.
31 down to 0, like this. Okay. Suppose if you want to develop 8 cross 8 memory, we want to develop 8 cross 8 memory. Now tell me.
Reg 7 down to 0.
Hmm,
And then
Mem
hmm,
7 down to 0.
7 down to 0. So
Sir,
total,
let me
yeah.
ask one question regarding this array.
Uh,
Suppose we are only storing one bit in the case of 5 and 9 and all. So how this compiler understand the rest are just ignored, right? Just
uh,
the go to the previous slide. Right.
Previous slide, okay.
So here, while
Uh,
storing the right side of the screen, as you can see, 101, we are only storing the MSB.
uh,
I mean
uh,
LSB. So,
uh,
but how does this compiler understand that it is 5, it is 9, it is some other values and
Okay, actually here you given the 5.
593?
So 5 means internally it will be converted into binary only. So
Okay,
this
but
is actually zeroth location. A of 0 is actually zeroth location. And A of 1 is first location. A of 2 is second location. So as I told you first, no, reg A. Reg A means how many bit?
single.
One bit, single bit. So that's why
single.
See,
it is
sir,
storing
what I am
one
asking
bit.
is,
Uh,
once we are assigning, this means we cannot retake this 5, right?
mm,
A of
mm.
0 no longer will be having 5. It will be having a single value like 1 only. We won't be able to recapture what it was stored, right?
Yeah. It will be converted into binary and LSB will be stored.
Mm. And suppose we are again accessing A of 0 and all means we won't be able to get that decimal 5 or
That
decimal
will be
value.
overridden. That will be
Ah,
overridden. Yeah,
so
that
that
will
will
be
be.
overridden. Yeah. Okay. Okay. Oh, yeah. So this is about suppose like if you take a module, let us take module test. These are some examples. Reg, I am declaring some memory. Reg 7 down to 0, mem of 1 down to 0. So what is width and depth?
Two
Sir,
What is the
width
width
location.
of
is
memory? 8
width
bit. What is the depth?
2 bit, two
2 bit.
location.
Two
Two.
locations. 2 bit. Two
Correct.
locations. Okay. So here I am writing initial begin. Initial begin. I am giving mem of 0 equal to 8 tick binary 1000 underscore 0111. Okay. And mem of 1 equal to 8 tick h12. Okay. And end module. Now tell me how in the memory location how it will store.
Sir,
Sir, in the
sir,
zero, on the
0
zero
total how many
location,
locations? Two locations.
two
One.
locations.
Two locations.
One
First
zero.
location what it will store?
100.
100000111.
1000
0.
0111. Yeah. In second location,
Sir, it will
zero,
It's
be
zero,
1
zero,
will be
zero
converted. Zero
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 zero one
zero one and zero
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 zero zero one and
one
zero
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 one
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 zero.
zero.
zero
So as I told you, when you give any number, it will store in terms of what binary only.
binary.
Okay.
yes.
Yeah. Next, if you see, suppose one more example, module test, module test. I'm giving reg 1 down to 0, mem of 1 down to 0, initial begin, mem of 0 equal to 2 tick binary 1 0, mem of 1 equal to 2 tick binary 1 1. Okay, and end module. Now tell me the value in this. So
1011.
how many locations?
2.
Two
Two
locations.
2 bit.
locations. Each location can accommodate how many bits?
2 bit.
2 bits.
Each one. I mean,
Each
2.
two, no?
Each
Two,
2.
two.
Two bit, two
So
bit, two
zero,
bits.
one. Okay. So actually
10.
this is actually one. So what will store? 1 0 and 1 1. Okay. So these we call as what? Content of the location. Contents. Okay. These we call as contents. Okay. And
Yes.
so this is actually we call as depth depth of the memory. And this one we call as what? Width of the memory. Okay. So this is
Yes, sir.
actually we call as index, memory index. Is it fine?
Yes.
Yes, sir.
Okay. Yeah. Next, suppose uh, uh, if I give the same value, mm, suppose if I give like reg, if I declare reg 1 down to 0, mem of 1 down to 0, mem of 0 equal to 2 tick binary 0 1, and mem of 1 equal to 2 tick binary 1 0. Okay, so two locations will form. Two locations will form. Here this is 0th and 1. So 0 1 will store and 1 0 will store. So can I access this LSB bit?
Yeah.
Can I access?
Mem of 0 of 1.
If you want to access this LSB bit,
First we need to
Yes, sir.
find the depth, then width. Like
Mem
how we can access? How we
zero.
can access?
Mem of 0 of 0, sir.
0 of 1.
That will come in the mem of 0 means that will come in the system Verilog. One
Okay.
dimensional array, two dimensional, 2D array, 3D array. So we have only like here normally vector slicing is not possible. Vector slicing is not possible with respect to array. Not possible. That means what? This is actually packed. Packed. Like integers, I told you, no?
Yeah.
Integer. So like that, it is packed. We can't access. We can't access the single bit in the memory location.
Yes, sir.
Okay. Yeah. So this is about today's session.
Sir,
I will show
sir,
you the code. Yeah.
sir, one of our fellow was suggesting like variable name, then in the square bracket a number, then again square bracket a number. Sir, this strategy will not work.
This example he asked that one. Huh?
No, 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 no. Just
Uh,
like Shiraj or other, someone
uh,
has told sometime some
hmm,
minutes before
uh.
to access a single. Sir, go to the next slide.
Next slide.
No, no, not this one. The final
Uh,
slide we were on the.
uh.
Yes. Suppose you have asked us that that LSB bit. Suppose we want to access that bit, and someone has suggested, can we deploy a syntax like variable name, then in the first square bracket a number, then in the second square bracket one more number. So this strategy will not applicable here.
No, no, it's not applicable. You will get error, compilation error. So with respect to arrays, so
Hmm.
vector, I told you, vector means what? I told you one example. Vector slicing is possible, but if you combine vector with arrays, with respect to
Hmm.
arrays, that is
Hmm.
packed data type. We can't access the single bit or like that. This is actually
Okay.
packed. This is actually what? This is 2 bits combined. 2 bits combined. We can't access the single bit like this.
Yes,
Okay, this
sir.
is actually what packed. Okay, suppose
Yes.
I will tell you one example. Suppose 8 cross 8 RAM is there. Okay,
Hmm.
so 8
Hmm.
cross 8 RAM means so total how many locations?
8 locations.
8 locations. Okay, so
Hmm.
8 locations are there. So this is what 0 to 7. Okay, so
Hmm. Hmm.
total. So we will decide how much is your memory means what? This is actually 8 bytes.
8 byte memory. Yes,
Okay,
sir.
one
Yes.
kilobyte, 1 kilobyte. Okay,
Hmm.
so
Hmm.
1 megabyte, 1 megabyte. Byte
Hmm.
is
Hmm.
actually what we call a group of 8 bits.
8 bits.
Group of 8 bits. Okay,
Hmm.
so
Hmm.
that means uh, in this memory location, can I access this bit?
Mm.
Or if I am using this RAM or ROM,
Hmm.
processor want to access this memory, so this will access according to this address location and it will access 8 bits of data. No,
Yes,
it
sir.
can't access this one.
Yes, sir.
Understood? So it can't access the single bit. This 8 bits are what packed. These 8 bits are what packed. We
Pack.
can't
Pack.
access. So vector slicing is not
Possible here.
possible for
Array.
memory like arrays. Arrays. Did you understood? Means
Yes.
practically, if we take processor can access only like depending on the address location, it can access 8 bits of data. It can't access like 3 bits of data from here, no? Okay.
Yes, sir.
So that's why with
Yes, sir.
respect to arrays, vector slicing is not possible. Okay.
Yes,
So
sir.
sir, to access it, so like we get that specific data onto a vector and then we can vector
Yeah,
slice.
yeah. Only vector only we can use. Yeah, yes. Mm.
Okay, sir.
If only vector we are using means vector slicing is possible. That example I told you now. So
Yes,
vector
sir.
slicing, I told you that example. But it is a combination vectors with array means it's not possible.
Yes, sir. So like in
Okay.
this scenario, we just store that a specific value in that location onto a vector and then we can use vector slicing.
Yeah, we can use. Okay.
Yes, sir. Okay,
There
sir.
should be not array. Suppose in this example, suppose reg 1 down to 0, m. Okay. And so that is m equal to what? Here you can write a 2-tick binary 0, 1. Okay. Now what
Yes, sir.
happens here? Two locations will form horizontally, and this is 0, 1. Now I can access this bit. Why? This is a vector.
Yes, sir.
But if
Yes,
you combine with array, that becomes packed.
Yes, sir.
Understood? Yeah.
yes, sir.
Yeah. So I'll show you some programs you tried that programs. Huh?
Yes, sir. Sir, sir, mine there is a request to please get some our gets make some make us familiar with the graphical user interface of Quartus because
Okay, okay.
Quartus I have
Means
not
we not yet
used that.
started the programming. No, we are in the basics only. So when we start the
Okay, okay, fine.
programming and test bench, then I can
Sure,
show
sure,
you. Okay, yeah.
sure.
So we are
Sir,
in
one more
the
thing tool.
basics only.
Sir, one more thing tool related questions. When I installed the GVim, I received three kinds of setups there.
Okay, okay, okay,
So,
okay. Yeah, yeah.
uh, one is GVim
Depends
9.2.
on processor. Depends on processor. So if you download, if you
Uh,
open this,
no,
yeah.
actually,
Mm.
yes, I
Six,
downloaded and I
you need to
installed it.
download a
So
64
on
bit
my
installer.
desktop,
Hmm.
three icons appeared.
Okay, okay. It's fine, fine. It's fine.
64-bit installer
You
and
need to
three
use this
icon
one. You
came
need to
on.
use this one. Yeah, I also got three icons. You need to use
Just a minute. Which
open
one?
this GVim 9.1.
Which one? Which one, sir?
GVim 9.1 is there now.
Okay, okay,
This
okay.
one you need to
Got
open.
it now.
Yeah, yeah.
We
I
have
also
to
got
skip not the easy and read
read
only.
only is there
So
now. Yeah, so
left it.
you need to
Okay,
use this only, GVim.
got it now, sir.
Okay. Yeah, yeah. Any other queries? Yeah. So
Okay,
this is
okay,
actually
okay.
example related to vector. Okay. So this is the example related to vector.
No, sir.
So here, this is the code. This code also I will share you. Module vector example reg 7 down to 0 data. So this is how many bit vector? 8-bit vector, no? Like byte. Okay.
Sir, enlarge the font size. Yes.
Yeah, yeah. Now it's fine.
No, it's fine. It's fine.
Module vector example. So reg 8 bits 7 down to 0 data. This is the 8 bits of data. And wire 3 down to 0 nibble. You know nibble. Nibble is actually what?
Group
Nibble
of
is
4 bits.
a group of 4 bits. Okay. So I'm assign nibble equal to data of 3 down to 0. So I want to access lower 4 bits of data. So I'm assigning this. Initial begin, I'm assigning the data. Data equal to what? 8-tick binary 1010 underscore. Underscore is actually readability only. 1100. Okay. So
Yes, sir.
hash 10 dollar display data equal to percentage b nibble equal to percentage b data comma nibble end and end module. Okay.
Hmm.
So can you expect the output of this code?
Sir, one second. Before get initializing the data, we are using the nibble function. The nibble equal to data of 3 is to 0 we are doing. Before
Assign,
getting the data.
assign. Yeah, yeah,
Ah,
yeah.
why you do like that? After getting the data only you'll be doing it.
After getting the data only, yeah.
Like
Hmm.
the case of see here initial begin. After that only we are mentioning what kind of data we are getting. Uh,
Actually, like, okay, so this is not sequential. This is parallel.
uh,
Assign will execute parallelly. Initial also execute parallelly.
okay, that I
Okay.
got
Now is it clear?
it. Yes,
Okay. Okay. So select all, copy, and I will execute in EDA playground. Can you execute in Vivado?
yes.
Huh?
Sir, I have to ask a question. Can you please go to the code again in
One
the
second.
GVim?
Okay.
Sir, there is a statement assign nibble and this, and second is initial begin. So
Hmm.
these two will together run in a concurrent manner. Is that right, sir?
Yeah, yeah.
Together. But sir,
So here, hmm.
yeah, but inside the initial, all the statements written will be run in the sequential manner. Is that right?
Between the initial begin, this is sequential.
Sequential.
This is
Okay.
sequential. Okay.
But when
This will be
initial,
executed. This will be
yes.
executed. After this, this will be executed. But
Okay.
this is actually assign block is this is one block. Initial
Hmm.
is one more block. So both will be executed concurrently, parallelly.
So suppose in a program I have first assign, then I have one initial, then again I have one initial, and again I have one always. So
All
all
will
these
execute concurrently. All will execute
concurrently.
parallelly. Yeah, concurrently. Yeah. All will
Got it,
execute
sir.
parallelly. Yeah. Okay. Yeah.
Okay, got it, sir. Got it.
So copy this code. Uh, paste here. Tools and simulators. Aldec Rivera and save this code, run this code. So what is data? One
One
zero
zero
one
one
zero
zero
double one double zero nibble equal to
one
double
one
one
zero
double
zero.
zero double zero. Okay. So this code can you check in Vivado?
Yes, sir.
Okay. You can check in the Vivado. Okay. So this is the example related
Yes,
to
sir.
what array. Okay. If you see the array, yeah, module array example. I'm declaring. So how to declare reg 7 down to 0, memory of 3 down to 0. So what is the
Yeah.
depth of the memory? What is the width of the memory?
Width is 8 bits,
Depth
depth is
Uh,
four location.
Width is 8
Four.
bit, that is vector. Depth is 4 bits. Okay. So I am declaring integer I, initial begin. Memory of 0 equal to 8 tick, yeah, 8 tick HA1. Memory of 1 equal to 8 tick HB2. And memory of 2 equal to 8 tick HC3. Memory of 3 equal to 8 tick HD4. Okay. I want to
Yes.
display. For displaying, I am using for loop. For I equal to 0, I is less than 4, I equal to I plus 1, begin dollar display memory of percentage d. Actually memory percentage d is actually this is a integer value equal to percentage h comma I comma memory of I. Okay. End. So this begin and end. Again initial begin is there, no, this begin and end. Okay, this begin, this end, and end module. Okay, this code is fine. Did you understood?
Yes.
Uh, mm,
Sir, one second. Memory inside the display memory percentage is 0 dear. What is 0?
0D means actually zero where you are using means if you are not using zero means you will get some more space. So in order to use in order to decrease the space you are using 0D.
Okay, sir.
Okay. Hmm.
The question was that 0.
Percentage h I comma memory of I.
First is okay.
If this code is fine,
Yes.
okay,
yes, sir. Yes, sir.
okay. Select all, copy, and we'll go to this EDA playground, new, and next paste. Select Aldec Rivera, save, and run. So any code first before going into the Vivado or Quartus Prime or Model Sim, You can see in the EDA playground. Okay, directly just save and run. If you need to select the simulator, so directly you'll get the output. See here. What is the output? Mem of 0 equal to A1, mem of 1 equal to B2, mem of 2 equal to C3, and mem of 3 equal to D4. So you ask
Okay.
that doubt, no? Just we'll remove this D. What will happen? We'll see. Save this
Hmm.
code and run this code. What I'm getting?
It's a unnecessary space.
Space I am getting, no? Yeah. So in order
Sir,
to remove that space, I am using 0D.
sir, just a small experiment. In the line 15, for the memory I variable,
Hmm.
please change its format specifier for the decimal.
Okay, it will convert into decimal. Yeah.
Yes, sir.
Save.
And without a space, zero. Oh, okay, okay. No, no,
Uh,
don't worry about the space.
uh, uh. Converted into decimal.
Got it, sir.
Okay. Binary means binary also it will display. Binary
Yes,
means the respective binary. Binary O means octal. Octal it will display.
yes, sir.
That octal binary and octal also it will display. O format specifier O means octal it will display.
Octal.
Octal value. Is it
Yes,
fine?
sir. Fine, sir.
So like this, yeah. So you can check this one in your Vivado also that I am not telling. Okay.
Yes, sir.